Model an acid gas cleaning process. In this video, you will model a standard gas sweetening process where diethanolamine, DIA, is the absorbent. Using the acid gas package, we will apply efficiency-based separations modeling to simulate the amine contactor and regeneration units. Using the acid gas package, we will be able to easily report amine loading values to judge the efficiency and viability of your gas sweetening unit. This example, a typical acid gas treating facility is simulated. A water-saturated natural gas stream is fed to an amine contactor. Diethanolamine at a concentration of 28% in water is used as the absorbing medium. The contactor, modeled as absorber, consists of 20 real stages. The rich amine is flashed from the contactor pressure of 6,900 kilopascal to 620 kilopascal before it enters the rich lean amine exchanger, where it is heated to the regenerator feed temperature of 95 degrees centigrade. The regenerator, modeled as a distillation column, also consists of 20 real stages. Acid gas rejected from the regenerator at 45 degrees centigrade, while the lean amine is produced approximately at 110 degrees centigrade. The lean amine is cooled and recycled back to the contactor. All calculations will be performed using the acid gas fluid package option for enhanced accuracy and capability. This video includes the following tasks. Task 1. Define the fluid package. Task 2. Build the amine contactor. Task 3. Add the regenerator and makeup. Task 4. Complete flow sheet and review results. Task 1. Define the fluid package. The acid gas property package allows for the rigorous modeling of gas sweetening processes. When setting up the acid gas package, you will note that certain molecular species are required for your component list. Those components include water, carbon dioxide, hydrogen sulfide, and supported amine or amine blends. In terms of the amine components, use the following list to ensure you are selecting supported amine components. Once employed in your flow sheet, the amine can be pure component stream or consists of a blend of supported amines. Once your component list has been defined, note that you can view generated heat-stable salts. These are salt components that are present during the acid gas treating process, but do not need to be explicitly listed by the user when defining components. Heat-stable salts are accounted for by the generated amine reactions available in hysys. You will generate and view these salts after you start the simulation. Start a new case. Click Add on the component list. Add the following components. Select the fluid package folder. Click Add. Please note that the acid gas package has already been selected, as hysys will default to this method based on your selected components. Go back to the component list you created. Click Add Heat-Stable Salts. These components are molecular species that actually exist in the process picture and are generated by various equilibrium chemical reactions. The hysys acid gas package is capable of developing and accurately modeling these reactions. Select the reactions folder from the navigation pane. You should be able to review 3 reaction sets. All required input for the properties environment has now been provided, so click the simulation button to enter the simulation environment. This concludes the first task in our video. Task 2. Build the amine contactor. With the acid gas package properties in place, you can begin building your gas sweetening flow sheet. The first step will be to define and calculate a hysys absorber model which will serve as the acid gas amine contactor. Add a material stream. Name the stream sour gas. Set the temperature to 25 degrees centigrade. Set the pressure to 6,900 kilopascal. Set the molar flow to 25 million standard cubic feet per day. Go to the composition form. Enter the following composition. Click OK. Now the sour gas stream is fully defined. Add another material stream. Name the stream diato contactor. Set the temperature to 35 degrees centigrade. Set the pressure to 6,850. Set the standard ideal liquid volume flow to 190 US gallon per minute. Go to the composition form. Change the bases to mass fractions. Set the diamine concentration to 28%. And set the water to 72. Now the amine stream is fully defined. Add a separator to knock any excess liquids out from the sour gas feed stream. Name the separator knockout tank. Name the vapor outlet gas to contactor. Name the liquid outlet liquid. The major operations in a gas sweetening flow sheet are the column models. The acid gas amine contactor modeled as an absorber, and the amine regenerator modeled as a distillation column. These column models will be set up a bit differently than typical hysys columns due to the strongly non-ideal nature of the amine acid gas separations. As a result, the contactor and regenerator column will make use of the aspen hysys acid gas package capabilities to ensure more accurate and refined separations calculation. Add an absorber column to the flow sheet. Name the column the contactor. Set the number of stage to 20. Set the top stage inlet to Dia2 contactor and set the bottom stage inlet gas to contactor. Name the overhead vapor outlet sweet gas. And name the bottom's liquid outlet rich Dia. Click Next. Set the top stage pressure to 6,850 and the bottom pressure to 6,900 kilopascal. Click Next. Set the optional top stage temperature estimate to 40 degrees centigrade and the optional bottom stage temperature estimate to 70 degrees centigrade. Click Done. Please note that the acid gas property package requires that the real trace be used in the contactor and regenerator operations. To model this in Aspen hysys, component-specific efficiencies are required for H2S and CO2 on a tray-by-tray basis. These proprietary efficiency calculations are provided in the column as part of the acid gas package. Tray dimensions must be supplied to enable this feature. Tray dimensions enable component-specific efficiencies to be calculated by estimating height of liquid on the tray and the residence time of vapor in the liquid. To supply required column dimensions for the acid gas calculations, navigate to the parameters acid gas page. Change the wear height to 25 millimeters and change the wear length to 1 meter. Set the section diameter to 4 feet. Keep the defaults for calculation type, column type, valve type, and all other acid gas tray settings. Click the Run button to run the column. Now the column has converted. Select the parameters efficiencies page to view the calculated CO2 and H2S efficiencies. This concludes the second task in our video. Task 3. Add the regenerator and the makeup. Now that the sweet gas product has been produced, you can turn your attention to the regeneration of the amine solution. Using an additional column model and appropriate makeup flow of amine, you can recycle the Dia solution and complete the flow sheet. Add a valve to your flow sheet. Name it Rich Valve. Set the inlet stream to Rich Dia. Name the outlet stream Dia2 Flash. On the worksheet tab, set the pressure of Dia2 Flash to 620 kilopascal. After the rich amine passes through the valve, a fraction of the material flow vaporizes. Send the rich amine on to a separator operation. Name the separator Flash Tank. Name the vapor outlet flash vapor. Name the liquid outlet rich to lean rich heat exchanger. The rich amine exiting the separator must be preheated prior to being fed into the regenerator column. Add a heat exchanger. Change the name to lean rich heat exchanger. Set the tube side outlet to rich to lean rich heat exchanger. And set the tube side outlet to regenerator feed. Set the shell side outlet to regenerator bottom. And set the shell side outlet to lean from lean rich. To the parameters page. Change the heat exchanger model to simple weighted. Set the shell side delta P to 69 kilopascal and the tube side delta P to 69 kilopascal as well. On the worksheet tab, set the temperature of regen feed to 95 degrees centigrade. The amine regenerator is modeled as a distillation column. There are 20 real stages, 18 stages in the column section, plus a reboiler and a condenser, just as you did on the DIA contactor column. You will provide tray information which will allow the acid-gas package to calculate efficiencies for the acid-gas components H2S and CO2. The regenerator will also incorporate an adaptive damping factor. This allows hysys to determine an appropriate damping factor based on the behavior of the calculated equilibrium and heat spec errors. Working with and adjusting the source or damping factor can help to ease and speed up convergence in columns with strongly non-ideal molecular species. Such is the case in the amine regenerator given the primary species are the water and sour gas component. Add a distillation column. Change the name to amine regenerator. Set the number of stages to 18. Set the L stream to regen feed. Set the L stage to 4 mean tower. Set the condenser type to 4 reflux. Set the overhead vapor outlet to acid gas. Set the bottoms liquid outlet to regen bottoms. Name the condenser energy stream. And the reboiler energy stream. Click Next. Keep the default reboiler configuration once true and the default reboiler type selection, regular hysys reboiler. Click Next. Set the condenser pressure to 190 kilopascal. and set the condenser pressure drop to 15 kilopascal. Keep the reboiler pressure drop to 0. Set the reboiler pressure to 220 kilopascal. Click Next. Keep the temperature estimates blank. Click Next. Click Done. Go to the Design Monitor page. Click Add Spec. Add column temperature. Set the stage to condenser. Set the value to 45 degrees centigrade. Add another spec. Column duty. Set the value to 14 million kilojoule per hour. Add the third spec, column draw rate. Set the stream to acid gas. Keep the default flow basis. Set the value to 1.5 million standard cubic feet per day. Activate only the temperature on duty. And deactivate any specification with unspecified value. We forgot to set the energy streams of the duty. Set the energy stream to boiler Q. Now navigate to the parameters solver page. Change the dumping option to adaptive. Go to the parameters acid gas page. Keep the default calculation type. Change column type to sieve. Set the section diameter to 1 meter and wear height to 50.8 millimeters. After the column solves, move to the performance acid gas page to view some of the amine process specific results. To account for mass balance, a makeup of amine solution must be included. This is to account for any lost water and dia in the sweet gas, flash vapor, and acid gas streams. And instead of performing these makeup calculations manually, you can make use of the new makeup unit operation. This unit operation automatically calculates water and amine makeup flow requirements based on a defined outlet conditions. Add a makeup operation to your flow sheet. Name it makeup mixer. Set the inlet amine stream to lean from lean range. Set the outlet amine stream to dia to cold. Set the dia concentration to 28 and the total flow to 190 US gallon per minute. This concludes the third task in our video. Task 4. Complete the flow sheet and review results. The last step of building an acid gas treating simulation is to complete the lean amine recycle loop. Close the loop and converge the model. Once the model solves, use the acid gas package specific reports form the column model to view amine loading values and determine the efficiency of the unit. Add a Euler operation to your flow sheet. Emit Euler. Set the inlet stream to the to call. Set the outlet stream to pump. And the energy stream. Set the delta P to 35 kilopascal. Add a pump. Set the outlet stream to recycle. Aim the energy stream. Set the to recycle temperature to 35. At this point, the only missing parameter for your flow sheet, the pressure of the to recycle stream. Rather than defining this term directly, you will set operation to define it relative to the gas contact stream pressure. The set operation is a steady state unit operation used to set the value of a specific process variable in a relation to another process variable in your simulation. The relationship is between the same process variable in two like objects. For instance, the temperature of two material streams. Add set operation to your flow sheet. The target variable. Select the to recycle. And select the pressure variable. For the source, select gas to contactor. Navigate to the parameter tab. Set the multiplier to 1 and the offset to minus 35 kilopascal. Use the amine recycle flow loop, add a recycle operation to your flow sheet. Select the L stream, to recycle, and select to contactor as the outlet stream. Set the composition sensitivity to 1. This ensures tighter convergence than with the default sensitivity. Concentration of acid gas components in an amine stream are typically expressed in terms of loading, defined as the number of moles of the acid gas component divided by the number of moles of the circulating amine. The acid gas package in aspen hysys is is capable of automatically calculating and reporting acid gas looping. Formally, these parameters would have to be calculated manually using a spreadsheet or some other offline means. Open the contactor, navigate to performance acid gas. In lean amine and rich amine, you can see the H2S loading and the CO2 loading. This concludes the last task in our video. Thank you for watching.